Using a float switch to control a deep well submersible pump connected to a 240-volt power supply requires careful consideration to ensure safety and proper operation. It is technically possible to use a float switch to control only one leg of the 240 volts going to the pump controller. However, doing so is generally not recommended due to potential problems. Firstly, switching only one leg of the 240-volt power supply can create an unbalanced load on the pump motor and controller. An unbalanced load means that the current flowing through each leg of the circuit is not equal. This can lead to overheating of the motor windings, reduced efficiency, and premature failure of the motor or the controller. Secondly, most electrical codes require that both legs of a 240-volt circuit be controlled simultaneously. Switching only one leg could be a violation of these codes, which are in place to ensure electrical safety. Addressing the question of whether there is an electrical hazard with a 120-volt potential in the water in the cistern, the answer is yes, there is a significant electrical hazard. If one leg of the 240-volt power supply is not disconnected and 120 volts remains present in the water, it creates a shock hazard. Water is a conductor of electricity, and anyone who comes into contact with the water could experience a dangerous or even fatal electric shock. Now, let's discuss the recommended solution for safely and effectively controlling a deep well submersible pump using a float switch. Firstly, it is recommended to use a float switch specifically designed to control both legs of the 240-volt power supply. These switches are designed to disconnect both legs simultaneously when the water level in the cistern drops below a certain point, ensuring that the pump is completely energized. Secondly, ensure that both legs of the power supply are disconnected when the float switch is in the off position. This can be verified using a multimeter to check for voltage at the pump controller when the float switch is in the off position. There should be no voltage present on either leg. Thirdly, it is highly recommended to install a ground fault circuit interrupter, GFCI, or equivalent protection device in the circuit. A GFCI is designed to detect even small imbalances in the current flowing through the circuit. If it detects a ground fault, meaning that some of the current is leaking to ground, it will quickly trip the circuit breaker, cutting off the power and preventing electrical shocks. A GFCI provides an added layer of protection in case of a fault in the pump, wiring, or float switch. In summary, while it may be technically possible to use a float switch to control only one leg of a 240-volt power supply to a deep well submersible pump, it is not recommended due to the risk of unbalanced loads, potential electrical code violations, and the significant electrical hazard of having 120 volts present in the water. The safest and most effective solution is to use a float switch designed to control both legs of the power supply, ensure that both legs are disconnected when the switch is off, and install a GFCI for added protection. Now let's delve deeper into the components and safety measures. First, let's discuss the float switch itself. A float switch is a mechanical device that consists of a float, a hinge or pivot point, and an electrical switch. When the water level rises, the float rises, causing the switch to change state. When the water level drops, the float drops, and the switch returns to its original state. There are different types of float switches available, including tethered float switches, which hang from a cord, and rigid float switches, which are mounted on a pipe or bracket. The type of float switch you choose will depend on the specific application and the physical constraints of the cistern. Next, let's consider the pump controller. The pump controller is an electrical paddle that houses the components needed to start, stop, and protect the pump motor. These components typically include a circuit breaker, a contactor, and an overload relay. The circuit breaker protects the circuit from overcurrents and short circuits. The contactor is an electrically operated switch that controls the flow of power to the pump motor. The overload relay protects the motor from overheating due to excessive current draw. It is important to ensure that the pump controller is properly sized for the pump motor and that it is installed according to the manufacturer's instructions and local electrical codes. Now, let's talk about the importance of grounding. Grounding is the process of connecting electrical equipment to the earth through a grounding conductor. Grounding provides a low resistance path for fault currents to flow back to the source, which helps to trip the circuit breaker and prevent electrical shocks. All electrical equipment, including the pump controller, and the float switch, should be properly grounded. The grounding conductor should be sized according to the electrical code and should be connected to a grounding electrode, such as a ground rod or a metal water pipe that is in direct contact with the earth for at least 10 feet. In addition to grounding, it is also important to use proper wiring methods. All wiring should be installed in accordance with the electrical code and should be protected from physical damage. Wires should be properly sized with the load they are carrying and should be terminated in approved electrical boxes or enclosures. Connections should be made using appropriate connectors and should be tightened securely. It is also important to use the correct type of wire for the application. For example, submersible pump cable is designed to be submerged in water and is resistant to corrosion. When working with electricity, it is always important to follow safe work practices. Firstly, always disconnect the power before working on any electrical equipment. Secondly, use insulated tools to avoid accidental contact with live wires. Thirdly, wear safety glasses to protect your eyes from debris. Fourthly, never work in wet or damp conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Let's reiterate the importance of using a GFCI. A GFCI is a life-saving device that can protect you from electrical shocks. It works by monitoring the current flowing through a circuit and detecting any imbalances. If it detects an imbalance, it trips the circuit breaker in a fraction of a second, cutting off the power and preventing a shock. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. They are also highly recommended for use with deep well submersible pumps, especially in situations where there is a risk of contact with water. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. The GFCI should be installed in a readily accessible location and should be tested regularly to ensure that it is working properly. To test a GFCI, press the test button on the device. This should trip the circuit breaker and cut off the power. If the GFCI does not trip, it may be defective and should be replaced. In conclusion, controlling a deep well submersible pump with a float switch requires careful attention to safety and proper installation. Using a float switch designed to control both legs of the power supply, ensuring that both legs are disconnected when the switch is off, installing a GFCI, properly grounding all electrical equipment, using proper wiring methods, and following safe work practices are all essential for ensuring the safety of yourself and others. While controlling only one leg of a 240-volt circuit with a float switch might seem like a simple solution, it introduces a number of risks that should be avoided. The unbalanced load can damage the pump motor and controller, violating electrical codes can lead to fines or other penalties, and the presence of 120 volts in the water creates a serious shock hazard. By following the recommended solutions and taking the necessary precautions, you can ensure that your deep well submersible pump operates safely and reliably for many years to come. It is always advisable to consult with a qualified electrician to ensure that all electrical work is performed in accordance with local codes and regulations. Let's also address potential issues related to corrosion and water quality. In a cistern environment, electrical components can be exposed to moisture and potentially corrosive substances. Ensure that all electrical connections and components are rated for wet locations and are resistant to corrosion. Regular inspections should be conducted to check for signs of corrosion and to replace any damaged components. Water quality can also affect the performance and lifespan of the pump and float switch. Sediment and debris in the water can clog the pump intake and damage the float switch mechanism. Consider installing a filter on the pump intake to remove sediment and debris. If the water is particularly corrosive, consider using a pump and float switch made from corrosion-resistant materials. The type of wire used for the submersible pump is also important. Submersible pump cable is specifically designed for use in wet environments. It is typically made from a durable, water-resistant material such as cross-linked polyethylene (XLPE) and is rated for direct burial. The cable should be properly sized for the pump motor and should be installed according to the electrical code. Avoid using standard electrical wire, such as non-metallic sheathed cable (NMB), in submersible pump applications, as it is not designed for wet environments and can quickly deteriorate. The size of the wire used for the submersible pump is determined by the ampacity of the pump motor and the length of the wire run. The electrical code provides tables that specify the minimum wire size required for different ampacities and lengths of run. It is important to consult these tables to ensure that the wire is properly sized. Using undersized wire can lead to voltage drop, which can reduce the performance of the pump motor and can even damage it. Voltage drop is the decrease in voltage that occurs along a wire due to the resistance of the wire. The longer the wire run and the higher the current, the greater the voltage drop. It is important to keep voltage drop to a minimum to ensure that the pump motor receives the proper voltage. Finally, remember that working with electricity can be dangerous. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. An electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with local codes and regulations. They can also help you to select the right equipment and materials for your application and to ensure that your electrical system is properly grounded and protected.